All right, so let's look at another example unrelated to uh, black bears. So in a study reported on October 29th, 2012 on the Flurry blog, the mean age of tablet users is 34 years. Suppose the standard deviation is 15 years. Take a sample of size 100. So we got four questions. Question one, what are the mean and standard deviation for the sample mean ages of tablet users? Question two, what does the distribution look like? Question three, find the probability that the sample mean age is more than 30 years. Question four, find the 95th percentile for the sample mean age down to one decimal place. All right, so um, let's first start with the information that we were given. And so what we got is the population standard deviation for the age of tablet users. So the age, that's our random variable in the population, that was 34 years old. And suppose that the standard deviation for the ages of tablet users is 15 years. And we're dealing with a sample size of 100. So question one is, what are the mean and standard deviations for the sample mean ages of tablet users? So if you're going to go out and take a sample size of 100, what would be the sample mean that you would expect to calculate from this population of tablet users? So with the central limit theorem, the population mean, we said it was 34. And due to the central limit theorem, we know that that is a point estimate for the mean of the sampling distribution. Okay, so the mean of the sampling distribution will be equal to 34. Now the standard deviation for the sampling distribution of the means is equal to the population standard deviation divided by the square root of our sample size. And that will be the standard deviation of the population was 15 divided by the square root of our sample size, which was 100. So it'll be 15 divided by 10, which is 1.5. So that's the standard deviation of our sampling distribution of the mean. All right, question two, what does the distribution look like? Good question. So the sampling distribution of the mean, so let's draw the sampling distribution of the mean. We know that that's going to be, let me write this. We know that that's going to be normally distributed. It'll have a mean of 34 and a standard deviation of 1.5. So let's draw that. There we go. And so the center of that is going to be the sampling distribution of the mean of the sampling distribution, which we calculated to be 34. And it has standard deviation of 1.5. So let's go 1, 2, 3 standard deviations above, and 1, 2, 3 standard deviations below. And we're going to be adding iteratively 1.5. So this will be 35.5, 37, 38.5, and going down the other way, 32.5, 31.0, and 29.5. All right, so that's the shape of the distribution that we're working with. Now, question 3 says find the probability that the sample mean age is more than 30 years old. All right, so what's the probability that the sample mean from 100, sample size of 100, is going to be greater than 30? Well, if we look at our distribution that we just drew, 30 is going to be somewhere right about there. And we want probabilities greater than 30, which means we want the area to the right of 30. So we want all of this area. Now, remember that the empirical rule, which is the 68, 95, 99, 7 rule, tells us the area under the curve between one standard deviation, between two standard deviations, and between three standard deviations. And this value of 30 is pretty close to 3 standard deviations below the mean. And we're including all of the area from a value close to 3 standard deviations below, all the way up to and passing 3 standard deviations above. So because of that, I'm going to expect that this probability, this area, is going to be somewhere close to 99% and probably higher. So what we want to do is we want to convert a value into an area. And so that's going to mean that we need to use some kind of cumulative distribution function to do that. All right, so let's see if we're going to use the Texas Instruments calculator. We want to use normal CDF. And the lower value is going to be 30. The upper value is going to be infinity, because we're going from 30 on up to positive infinity here. So to represent that on the calculator, we need to put E99. So to get an E, we need to use these blue capital E's here. So we'll hit second, comma, 99. And let's see, what was the mean? Our mean is 34, standard deviation is 1.5. So 34, standard deviation 1.5. So before I hit that, I'm going to leave that up so I can use the NumWorks calculator and I'll know what values I've got. So now I'm going to go down to the distribution app and go to the normal distribution. And I've got a mean of 34, standard deviation of 1.5. And I want the area to the right, so I want to use this third option. So we're looking for values of x that are greater than or equal to 30. Right, now this number on the right is going to change as soon as I hit enter. So we get an area of 0.996, and we should get the same thing here on the Texas Instruments. Yep, 0.996. So let's come back. So the probability that our sample mean from a sample size of 100 is greater than 30 is 0.9962, which is 99.62%. And compare this to what we expected, just based off our picture, that's pretty darn close to what we expected. And again, that was based off of the empirical rule. So even though the empirical rule kind of quote only applies to, really nice, um, plus and minus one standard deviation, plus and minus two, plus and minus three, you can still use it to estimate answers, right? Okay. Finally, question 4 is find the 95th percentile for the sample mean age. So the 95th percentile is going to be some value, k, where 95% of the other values are smaller than that. So this is a situation where what's given is an area, and what we need is a value on the x-axis. So in order to convert an area to a value, we need to use some kind of inverse distribution function, right? Um, so Texas Instruments calculator first. If you're using a newer version, then go to the distribution functions, go to inverse norm. And the area we want is 0.95 because I think we wanted a 95th percentile. Okay. So let me write this in here. So this area is 0.95. Okay. And we've got a mean of 34 and a standard deviation of 1.5. And we want the area to the left. All right, now let me leave that information up. All right, so this has the same information from before. And what's nice about the numworks is that you can do a CDF if you put in a value on the left, or if you put an area, it'll do an inverse, give you the value on the other side. But we do have to change the area here to be this first option. We want the area to the left. And the area that we want is 0.95. So that gives us a value of 36.467 and some change. And so from this picture, this is what we're looking for, right? Some value where 95% of the data is lower. Okay, so that looks good. Over here with the Texas Instruments, we'll go ahead and hit paste and enter, and you can see we're getting the exact same answer. If you have an older style calculator, let me go ahead and just bring that up, just because I do have it handy, and make that a little bit bigger. And let me share this. Come on. Zoom is fighting me a little bit here. Okay, share. All right, so if you've got an older calculator and you're using the program that I put in there, use this inverse n function, hit enter again. The area we want is 0.95. We're dealing with a mean of 34, standard deviation of 1.5. We want the area to the left, so it gives us 36.467. Okay. So the value that is the 95th percentile is going to be 36.5. All right. So that does it for that example. Let me know if you have any questions.